We know that an atom is made of three subatomic particles, the proton, the neutron, and the electron. What we need to know about those, what is their mass or relative mass, and what is their relative charge. Okay? The proton has a relative mass compared to all three of +1. The neutron mass is the same as the proton, which is 1. And the electron is essentially 0. It is a particle, it does have a mass. It's around 1/1000 something compared to the others, but we just assume it's 0. Yeah? It's negligible, we don't need to use it or count it in calculations. The relative charge of the proton is +1, the neutron has no charge, and the electron has -1. What that means is, it's negative, but it has exactly the same magnitude of charge as a proton. Although the proton is way more massive than the electron, the charges are the same size, they're just the opposite sign. Okay? So that's what we need to know about those. We also need to be able to use the symbols. For example, you could have C12-6. This is a carbon element. This is the mass number. This is the atomic number. The mass number represents the number of protons plus neutrons. The atomic number at the bottom represents just the proton number. But also, because we know that atoms are neutral, it technically tells you exactly how many electrons that are orbiting in the shells as well. Okay, so technically it's the proton number, the charge, but it does tell you that there are 6 electrons in there as well. 12 for the mass number is how many protons and neutrons. These could be called nucleons in an exam. Okay, a nucleon is just a particle that exists inside the nucleus, so it could be a proton or a neutron. If you want to find out how many neutrons there are, then all you do is the mass number, which is both proton and neutron, subtract the atomic number, which is just protons, and it tells you how many neutrons there are in the atom. Okay? Finally, on inside atoms, we have something called isotopes. Alright? You could have carbon 12 and 6, and then you could also have carbon 14 and 6, or you could even have carbon 16 and 6. All of these are carbon elements. Okay, they're all elements of carbon. They all have the same atomic number, meaning that their proton number inside the nucleus is the same. The electrons orbiting the outside of the nucleus is the same, except for the mass number changes. So an isotope is the same element with the same proton number, but different neutron number. Okay? An isotope has to be the same element. You can't have carbon 12-6, oxygen 14 and 6, for example, if that even existed, and say, oh, they're isotopes because they have different numbers of neutrons. Okay? It has to be carbon and carbon with the same proton number, just different neutron number. Okay? They are isotopes of the same element. Alright? Luta, stop it for me.